Good afternoon, everyone. The topic of today's seminar is evaluation of machine translation output. First, I would like to introduce human evaluation measures of machine translation output. There are two major features of a translation. They are intelligibility, which means the comprehensibility, and fidelity, the adequacy. They were proposed in the first report on manual evaluation of machine translation. To evaluate quality, a score for each of these two criteria will be assigned. Also, as White proposed in 1994, adequacy, fluency, and comprehension as a standard set of ideas for MT evaluation. They require a score for each of these three criteria. Also, the following criteria were identified by Popvik in 2020 as the most important approaches to human assessment. The first one is adequacy. Also, we can use accuracy, fidelity. They reflect how effectively the translated text captures the sense of the original. A second is comprehensibility. It describes the degree to which readers should be able to grasp the translation without having access to the original text. And human assessment methods could be divided into traditional types and advanced types. With the traditional types focus on intelligibility, fidelity, fluency, adequacy, and comprehension. And the latter will use text-oriented extended criteria to utilize post-editing, segment ranking, crowdsourced intelligence, and it will also revisit traditional criteria. The ranking of two or more translations of the same sentence in terms of quality is intuitive. It doesn't need so much for prices criteria, but it is potentially problematic as comparing low, poor quality translation is unreliable. Therefore, the main issues would be we have to compare just two or more multiple translations, and we also have to think the level of agreement among rankers. And we have to use ranking scores to assess systems. So human evaluation metrics would consider the following criteria, and we will try this in tonight's workshop. For adequacy and fluency, there will be 5 scales from 1 to 5. And the ranking of different MT systems would be from best to the worst. And we also will use yes and no assessments. And we'll try to use the subjective sentence error rate from perfect to absolutely wrong. As for usability, we will take a look at good, useful, or the worst scenario, useless. And we have to also think that whether post-editing effort is required. And sometimes we have to conduct error analysis. Speaking of error, the classification of the errors of a machine translation system was proposed in 2006. Let's take a look. In general, errors could be divided into 4 types. They could be missing words, or could be some errors in word order, or some incorrect words, or some unknown words. In particular, for missing words, it could be content words or filler words. For word order, it could be at the level of word or at the level of phrase. For incorrect words, it could be incorrect form or actual words, or errors in style, or error in sense, or error in idioms. For unknown words, it could be unknown stem or unknown forms. As for continuous direct assessment, it was adopted as official translation metric in the workshop conference on machine translation shared task in 2019. Instead of adopting a discrete scale, a continuous score between 1 and 100 is assigned in this manner. And adequacy and fluency were studied as guiding criteria in this assessment. So the ideal approach was to make adequacy the primary criterion and fluency as an auxiliary criterion where necessary. There are some challenges of human evaluation of MT output. The first is time it takes and the cost. During this procedure, the cost could be a lot, and maybe it takes longer time to have human evaluate the output of machine translation. Also, we have to consider the reliability and the consistency, because it is difficult to obtain high levels of intra and inter-code agreement. Also, human examination of MT output requires more effort and can take longer than human evaluation of human translations, because there is larger variety in the quality of machine translation. At last, we cannot ignore the factor of the human evaluators' subjectivity. They could have subjective opinions. So this is one factor we also have to consider. There appears one task-based evaluation. For example, the US government's machine translation functional proficiency skill project was developed as a method for task-based machine translation evaluation, which resulted in a skill of text handling tasks, such as topic detection, gisting, document filtering, and entity extraction, in terms of the ability to perform these tasks with potential poor machine translation output. Now, let's introduce multidimensional quality matrix, MQM. A group of knowledgeable specialists and professionals managed the open source MQM project, which was first sponsored by the European Commission in 2014. It provides a configurable list of quality issues and a method for users to get quality scores. In the meantime, it also offers a framework for describing and constructing unique translation quality measures. It is a thorough database of quality problems that can be utilized to explain specific metrics for some particular jobs. In addition, it has been used for some formal MT evaluation shared task challenges, such as the 6th Conference on Machine Translation. As for the drawbacks of MQM, the first is it requires a large amount of time and effort, also the cost, and it cannot address the good enough quality needs when it comes to post-editing. And it tracks too many unnecessary linguistic details. Also, it does not track error types that are specific to machine translation. To classify automatic quality assessment methods, we can start from two simple categories. The first is traditional assessment methods. The second is advanced assessment methods. To be specific, we can further divide them into three types. The first type measures the overlap in words and word sequences, as well as word order and edit distance. They will use simple n-gram-based word surface matching, as it is shown here, n-gram surface matching. It will take into consideration the three factors like edit distance, preceding, and recall, and word order. A second type will include syntactic and semantic information like part of speech, sentence structure, paraphrasing, synonymous, named entities, and multi-word phrases for deeper integration of linguistic features, as it is shown by this box, syntactic features and semantic features. A third type is deep learning models. It is a method that combines deep learning and neural network. The latter is quite promising. So the automatic metrics for MT output generally work by comparing the MT output with a set of reference translations of the source data. The following are some of the best known metrics in this area. The first is word error rate, WER. It is a standard metric for automatic speech recognition and one of the first automatic MT metrics. A second is BLEU, stands for Bilingual Evaluation Understudy. It is a widely used measure that accounts matches of n-grams or word sequences in some situation between the machine translation output and one or more reference translations. A third is METR, stands for Metric for Evaluation of Translation with Explicit Ordering. It is a measure that utilizes grammar and synonymy to batch align the MT output with the reference translations. TER is translation edit rate. It is an extension of the WER measure that allows for the movements of groups of words within the MT output. Next is human-mediated TER. It evaluates the output with TER using new reference translations created by human annotators that are as similar as possible to the MT system output. As for the current standard for automatic machine translation evaluation, we generally will refer to BLEU metric. It was proposed by IBM in 2002. The main ideas it contains include there would be direct exploitation of multiple references, and it will be calculated by counting the number of n-grams in the MT output, which also occur in the reference translation or a set of reference translations. It will use precision-oriented metric, which measures how much of the MT output is correct, rather than simply tell whether the references are fully reproduced in it. So the accuracy is more oriented in this measurement. For measure, the main ideas are it combines precision and recall as weighted score components. So there will be different weights assigned to precision and recall. And the final precision and recall would be considered as a component to measure it. It only looks at unigrams, which means single words rather than word sequences. And it compares MT output with each reference translation separately and takes score of the best match. And it will take into consideration the word inflection, synonymy, paraphrasing, and differences in word order. So it consistently outperforms BLEU when it is correlated with human judgment. To highlight the main difference between Measure and BLEU, Measure's match between MT output and reference translations take account of semantic equivalence. So it will take a look at inflections, synonyms, and paraphrases. Measure also utilizes precision and recall, while BLEU will impose a brevity penalty. Measure can adapt its parameters to improve correlation with different types of human judgment. Therefore, in conclusion, the correlation of Measure's result with human judgments is significantly higher, especially at the level of segments. For translation edit or translation error rate, the main ideas it contains include: it determines how many changes are required to convert the MT output into the reference translation. For example, how many word additions, how many deletions, how many replacements need to be done to convert MT output into the reference translation. Also, there is one single edit action called block motion. The most recent version is TRP, supports synonymy or paraphrase matching and configurable parameters. Older versions only counted literary word matches. Now the new version will take a look at synonymy and paraphrase. Also, it can be utilized as a rough gauge for post-editing. TR is calculated using HTR, which is a semi-automated measure that uses difference between before and post-edit MT output. It is used as its foundation. To conclude, the advantages of automatic metric include its fast and cheap with little human input required. In comparison, we know that the disadvantage of human assessment metric is it needs a lot of time and it costs a lot, right? And the advantages of automatic metrics also include it can be used during system development to test, so improvements can be made. As for its disadvantages, the first is it is necessary to have one or more reference translations of the same portions, with several translations being the ideal. And the metrics cannot be used to compare systems created utilizing various architectures in a trustworthy manner. So the subject domain and the target language determine how automated to human score mappings work. Therefore, higher quality MT output makes some automated metrics less sensitive. So the challenges of machine translation output, combining human assessment and automatic assessment metric, is to create and evaluate autonomous metrics for machine translation evaluation. Trustworthy human measurement are required. We need to find human measurement in this regard. Automatic machine translation metrics alone are not sufficient. Current automatic measurements are more or less imprecise and subject to bias. So it cannot offer adequate insight for error analysis. Also, different sorts of mistakes have different consequences depending on what kind of machine translation is being used and why it is being used. The second topic we're going to talk is post-editing of machine translation. Since the beginning of machine translation technology, post-editing of MT has been conducted as a practice, service, or research topic. And it has advanced a lot in recent years. Machine translation researchers initially viewed post-editing as an undesirable final step in MT development, even though it was acknowledged that interactions between humans and MT systems were inevitable for translations, especially for important, sensitive content. So even though people try to avoid it, it is unavoidable. We have to have the interaction between human and MT systems. So the types of machine translation post-editing can be simply divided into two kinds. The first is light post-editing. The second is full post-editing. In light post-editing, only small adjustments will be made to the machine translated text. Post-editors for this type of work just make required changes to grammar and spelling to ensure that readers can understand the material. They rewrite sentences that are unclear and correct any errors that machine made, but they do not edit to change the overall tone of the writing or the translations unless it is absolutely necessary for accuracy. They will not change the tone of the writing or the translations. These are major changes. On the other hand, full machine translation post-editing entails a complex procedure. So besides correcting errors, post-editors will make adjustments to improve style, tone, and even cultural and linguistic issues like idioms or other meanings. Post-editing typically actually means bilingual post-editing, as we can get experience from the translation tools. Both of the source and target text will be automatically displayed on the screen. So the three effort categories that make up post-editing effort would be cognitive. It's a mental processing that goes into making editing decisions. Technique, which means a mechanic effort needed in putting the edits into practice. And temporal, which means the time required by the activity, which comprise both cognitive and technical effort. These three effort factors are frequently used as a benchmark for contrasting post-editing with translation from scratch. So even there are different approaches, the most popular levels are light and a full post-editing. As published by the Translation Automation User Society, the guidelines to these three levels will be based on two standards of the expected target text quality: good enough quality and the quality which is similar or equal to human translation. This could be considered as roughly equivalent to light and full post-editing. The guidelines reflect the fact that the actual amount of editing required depends on both intended purpose of the text and the quality of the raw empty output, which means that the target quality is more likely to be a consistent parameter for post-editing guidelines than the degree of editing to be performed. So this is a graph showing the spectrum of human agents in the post-editing process. We can find that there is automatic post-editing, which is MT-centered. The other side is human-centered, which means post-editing with interactive or adaptive MT suggestion, or static post-editing is in between. So it is positioned between more leeway for variety, which means depend on viewpoint and the context of MT use, static posting can shift closer to either end of the spectrum. Could be more like MT-centered, or it could be more like human-centered. Okay, this is the end of today's seminar.